Okay, guys, good evening here, maybe good morning there. Good to meet you. My name is Liran Sorani. I'm from Webos. Itai, introduce yourself.
My name is Itai Onat. I'm from Intercept 9500.
Okay, great. Today we'll talk about analyze like a hacker. Let's review a bit the agenda. Just a moment. Okay, so in general, we'll provide you a short intro about Webos and Intercept 9500. We'll discuss different use cases that relate to government, enterprise, security agencies, different techniques that maybe hacking APT groups might use. And eventually, we'll talk about Q&A. You can start and write your questions during the whole session, and eventually at the end, we will answer. Okay, so about us. My name is Liran. I'm the business unit manager here in Webos, in charge of the cyber, the product, and the strategic part of the business. Itai?
Hi, I'm Itai Onat, CEO of a company called Intercept 9500. That's an Israeli lingo for, reminds us like A200, you know, the famous military intelligence unit. What we do in the company, it's a boutique company, and we do hacking related issues, early warning, cyber threat security, incident response, intelligence related issues, etc., etc.
Okay, thanks. So let's jump right into the use cases. So the first thing that I would like to talk is data leakages. As we know, it's a major phenomenon. We all saw it in 2017, already increased in 2018, and wow, it's a big boom in 2019. Itai, what can you say about that?
We've put the numbers here in the slide that you can see, but just from now, there's a new security report about the data breaches, and we can say that in the beginning of 2019, this year, in Q1, there are 1.9 billion records that are exposed. Huge numbers.
Okay.
And database breaches is an epidemic.
So in general, you can say that, you know, when we talk about the hacker side in the data leakages, there is any specific profile, any common techniques that you can elaborate?
Okay, I would say that there are three different kinds of hackers. APTs, mostly nation grade of hacking, and that's not relevant for us. You can't stop them really. You can try. most cases it doesn't work.
They are well funded, they are very good, large groups, they even manage like projects, like startups in some cases.
Exactly.
Yeah.
The things that are most relevant for us is the advanced hackers, and they try to hack and target, and they find a lot of things and enter. But the third one is the most surprising, I think. It's hackers without really a lot of knowledge of hacking, and what they are counting on is the human error. What they do is just search, use a search engine, Shodan in most cases, and then they find those databases that for a short period of time, someone left open and exposed to the internet.
I see. Now I read somewhere that actually phishing, okay, is one of the most easiest and most common technique, and actually it still works, you know, faking a domain or faking an email domain, sending someone on behalf of someone, like the boss of, etc., etc. This is still common in 2019?
Yes, again, new statistics, about 90%, 90, which is huge, is human error. When I mean human error, mostly clicking the wrong link.
Wow, simple as that.
Yes.
Amazing. So here we are in Webos. We just provided an example of state government, specifically in California. In this example comes out from collection one. Most of us that deals with the data breaches know about that. And in this example, it's a person that actually was leaked with the password. Of course, we sanitize the password. I must say that we encounter lots of database leaks. Our main sources are both cyber analysts that always explore the dark web and deep web and try to find the newest data breaches, as well as all the unstructured web and the dark nets where we actually automatically identify breaches and add it to our database breach detection repository. Okay. Anything else, Itai, from the numbers here?
The numbers are huge, as I said, both the number of breaches as well as the information itself. You ask, we most probably have it or can find it. And when we talk, usually people think about, okay, what you get is a username, password, it's credentials. Maybe if you're in the financial industry, you think about credit cards. But that's not the story. If you remember the Panama Papers, okay, so last week Romanian lawyers, about 37 if I remember correctly, were hacked. All the information is out there. So many companies are being hacked, and the information that is being leaked is not just using a password. It's files, secret, sensitive information about people, about the companies, about the R&D, whatever you want.
So in general, you know, if I'm a small company or even medium company, usually I don't have a lot of resources to protect myself. So in general, should the best practice here to have some kind of monitor service in order to find or to get some protection based on such kind of monitor services?
The answer is probably yes, but I would like to say that if you are a small, medium-sized company, not in the financial industry or any other high level of interest for hackers industry, most likely you are not, I don't want to insult anyone, but you're not interesting for the hackers.
Yes.
But hackers work in two different modes of operations. One, looking for an interesting target, which is not you in this case, but the other one is working statistically. You go to a search engine and you look for an open machine. And now if your security is not good enough and you leave open machines, you will be hacked, even if the hackers are not looking for you specifically. So first level of operation is having good cybersecurity, understanding that you should not leave open, unsecure places. Once you do that, yes, you would like to have some kind of monitoring. Why? Because there are devices that they have some kind of issues. They weren't patched. There are no patches for them. You can't really protect them. IoTs, we'll talk about them later. If that's the situation, you would like to know that someone is working, attacking, interested in that if he's a criminal.
Now, one thing that pops to my mind is that I read somewhere that major parts, or let's say parts of the data leakages, especially in sensitive documents, might be an internal job. Is this the case?
Internal job is something, again, you find a lot of statistics about it, but if you talk about internal job, like a malicious operation, someone was paying an employee to steal something,
right?
That's not the majority of the cases, not even half of them. There's just for an example, because it's a classic case, an Israeli company, NSO, I think today or yesterday was in the news for other issues, messing up with WhatsApp, but that's not the story here.
The VoIP,
They had an employee, a highly trained and capable IT guy. He wasn't very happy with his salary or promotion or whatever, and he was able to circumvent all the security means that were on the IT system of the company and steal all the secrets, all the source code and everything, and he was trying to sell it.
Okay.
And he was stopped just because he was trying to sell to the wrong guy, who just picked up the phone and told the company, someone stole your inside information, he's trying to sell it. Okay, so you have stories like that. It's not that it's non-existent, but most of cases, the problem with your HR, not trained enough or not disciplined enough, or make human errors. And this is the internal problem that leaves things open.
I see. Okay, thanks. Okay, so another example of a data leak, you know, I call it the small presence that hackers leave here and there. A lot of files that actually being published, and you know, and if you monitor and do it automatically wide enough, you bump into it. And this is just another example of FBI agent list. Of course, I covered most of the important information that you can see here, but this is another example of the last months that we bumped into. I think that the average number that we bump into when we talk about data breaches and compromised data, it's something like 2 to 3 million records per day, which is enormous.
Yeah, and this is going to big data. And about big data, we must remember a few things. A, you must have technology. You can't do things manually. It just doesn't work anymore. And B, the thing is with big data, okay, you brought the data home. It's in your server.
Yeah.
But you don't know about it. For example, you have a list of FBI agents. It's in your database, but you don't know about it.
Because it's streaming inside and you just have it as a raw data.
Exactly. And now, how do you know? If you are not actively looking with keywords like FBI or agent, this information will never pop up. So if you're a company and you are monitoring things, you must build a list of keywords to monitor the relevant things, like the name of the company, IP addresses, maybe phone numbers, name of C-level managers, things like that.
I see. Okay, good. Thanks. The second use case is the supply chain. We all know that it's pretty complex. There are many services today, and every company A gives services to B, gives services to C. Okay, you have here a lot of facts, but can you elaborate more about that?
Well, supply chain, it's I think the last buzzword and the last fashion among hackers. Hackers want money. It's not the hacker from 30 years ago that would like a T-shirt, I hacked the FBI, or I hacked
the prestige.
Yes, they're looking for money.
Yeah.
The money is in the large corporations, in specific businesses. They are under attack and have been for the last years or many years. They know how to protect themselves. So if you want in, the easiest way is to look for some kind of a subcontractor, and they are less protected and they don't think that they are targets. And then from them, you migrate to your target. I think that as an example for the American audience, Target is a very good example. It's from, I think, 5 years ago already, but the first time on record that a CEO had to leave his position and go home because of a cyber breach. And the thing that the cybersecurity in Target were well trained and did a good job. The problem was that some kind of a subcontractor, I think it was ventilation guy, he didn't protect his system. I think he was using a free antivirus and it wasn't automatically updated.
Amazing. Simple as that.
So he was easily hacked, and from him they migrated into Target, and now the story is well known.
Also, we know that, if we are talking about service layer, for example, the IT vendors or IT supplier, they are very major and mainstream channel where everybody go through it. They serve many enterprise companies. So this could be part of the weak link in the process.
Yes, exactly. And two things about that. One, when I talk to people, the example that I like to talk about is not IT suppliers, because people, unless they're from the industry, can hardly imagine it. I would like to talk about the garage of the cars.
The garage, yeah.
I want to infect all the cars. I don't go car by car. I go to the garage and infect the computer in the garage.
It's actually the service point.
Exactly, the service point. And from then you infect everybody. The same goes for the IT vendors. That's one thing. The other one, supply chain attack, I think it is well known that in the last month, I don't remember the exact date, with the Asus computers.
Oh, yeah.
Someone was attacking the very beginning of the process, and then what you get wasn't a piece of software. You could keep everything sanitized, but you bought a piece of hardware, and you weren't aware of that inside that hardware you had a small piece of software that was infected.
And it was through the update mechanism, if I'm not wrong, right?
Yes, exactly.
Okay, I see. Can you elaborate a bit more about the island hopping? If I'm not wrong, this is the part where actually hackers try to, ping. If I'll take, for example, a target like, I don't know, IBM, then they will try to find all the subdomains and all the supply chain that related to it, and actually try to build, like we try to build a bucket of thoughts, they build a bucket of domains or services.
Yeah, actually, it's mapping the entire supply chain and migrating what we call laterally from place to place, and things that are theoretically are not connected, and you can move among them. Then again, if I leave for a moment the IT industry and computers and software and talk about the tsunami in Japan that stopped the manufacturing process over there, so parts weren't being shipped to South Korea, and those parts weren't shipped to China, and those parts weren't shipped to Germany, and BMW stopped the manufacturing after 2 weeks. Same concept with the software. You go to a guy and you infect over there, and you jump to somewhere else, and you jump a second time and a third time and a fourth time, and eventually you get to wherever you want. And most of the attacks today would like this kind of a supply chain attack.
Mm-hmm. Thanks. So this is another example from our repository where we found the Hulu account leak. And Hulu is actually a video streaming technology, and actually they serve Comcast, which is another video channel, bigger one that actually use Hulu, but actually people use the Hulu accounts in order to access Comcast because the same guys that actually work in Hulu stored information and sensitive information about another credentials in Comcast itself. So this is another explanation, and you can see here the picture that actually we show the connection between them. On the right side, you can see some of the hacked accounts. Another list of facts from the supply chain. What you can say about that, Itai? You know, some important stuff like ballistic missiles, North Korea, you know, starting to be dangerous.
Yes, that's the examples, and what you have here on the slide are good examples of the first one. When you talk about South Korea, is when you attack one piece, which most probably was a physical one, like a motherboard or something like that. The second example here is talking about a software. But the concept here is to understand that you have a supplier, and even if you protect your first line of suppliers, they have their own suppliers. So you monitor yourself, and if you're doing a very good job, you're monitoring your supplier, but then you can't monitor the entire chain. And the attack vectors can be from any direction, like it's a physical part or a software part of this kind of island hopping, like someone wants to attack you instead of directly attacking you, like going from the first island to the last island, what we just talked in the last slide. They hope from island to island until they get to the result, which is attacking you.
So speaking about monitoring, you mentioned it in the context of monitoring the endpoints, you know, the physical services and the physical points, servers. But when we talk about monitoring like an early detection, I can take the same supply chain, the IPs, the subdomains, the whole chain, and just monitor it via some kind of dark web services or any kind of services that actually will provide me some kind of notification or early warning, if I may say.
Yes, okay. You know, I apologize for being a bit pessimistic, but when I give lectures in universities and places like that and talk about it, and specifically when I talk to our IT people, guys, I tell them, I'm sorry, but at the end of the lecture, after being very optimistic, which will be in a moment, I tell them, prepare your resignation letter. Guys, you can't have 100% security.
Yeah.
So you must take everything that you can and cover with whatever blanket that you can. Taking this kind of early warning of intelligence, of gathering information about attack technology, attackers' intentions, specifically about technologies that you have in your organization, or specifically attackers talking about your organization, is something that might be very, very helpful. We are working on incident response also, providing intelligence for incident responders. That's the place where we see the hackers that are already inside. It's not a theory whether they're going to be inside, they're already inside, and we see what they leak and how it works. Half of the attacks that we saw in the last half year were supply chain attacks. The vulnerabilities were mostly human related. To be optimistic, in most cases, I think we either could have told the firm that the attackers are planning to attack, or telling the firm that they were attacked because there are leakages. Hackers want to see freebies, and if we monitor and find the samples, we can early warning you were being hacked, but 2 months before the end of the process.
Wow, amazing. Okay, before we go to the use case, actually, I wanted to ask you, you mentioned to me before that actually when you take an analyst work, there is a few parts of it, but the part where you actually gather information is the most critical one, of course, but it might take a lot of time if you don't have some kind of, I imagine it like totally different feeds. It could come from social media, from blogs, from news, and also from the dark web. You need all of them in order to query and actually gather the base of information so you can analyze it, you can connect the dots.
I totally agree, but the thing is, I don't like this buzzword darknet. What is the darknet? Can you define the darknet? What are the boundaries of darknet? So hackers, and they are what interests us, they are human beings and they're all over the place. You can find hackers in Facebook, in Twitter, you can find them in application in a smartphone, you can find them in Tor network, you can find them all over the place. So you have to monitor those places. It's different kind of technologies, and you have to be all over the place. Russian hackers use a different language, Russian. Other than American hackers, different language from Spanish hackers. So you have to enter different chat rooms or different markets in order to bring that. So if you have a customer, a company, financial, manufacturing, government, it doesn't matter, and they want to do some kind of a risk analysis, and they ask you to go to the darknet and bring information, it's in the internet. There's no distance. The distance is you're 2 servers away. It's not you're 2,000 kilometers away. So the threat guys, the bad guys, might be Russians or Chinese or Brazilians or Americans. So you have to monitor all the places and all the languages. You can't do it manually. And even if you are there and you're going manually one by one, which will take you eternity, the size, the amount of data that you bring home and you have to go over it is something that no one can read. So the only way to bring the information to cover, you can't cover all bases, but most bases, is by technology. And the only way to go and analyze it and find interesting stuff is by technology. Manually is nice, manually is something that helps you on the edge, gives you the edge on top of things, but without technology, it doesn't work.
It's impossible almost. Yeah, so the last one, but not the least one, of course, is the IoT, Internet of Things, and SCADA and infrastructure. We all know that today, most of these processes becoming digitally, and they are all connected, either through a web, either through a VPN channel, but eventually they're connected. They need to be, in some cases, operated remotely, or at least controlled remotely. And this can create additional points of failure, okay? So what can you elaborate here?
We have the slide, but I would like to also elaborate and give some more examples on that. For example, SCADA. SCADA means that you go to the manufacturing line. It has to do with industry. Usually it's controllers that are 10, 20, 30 years old. You don't have cyber security embedded, and you want to connect them to networks. Even if your SCADA infrastructure is not connected to the internet, most places connect them to internal IT network. So if I hack your PC and migrate from there to your SCADA system, same thing for me as a hacker. What can I do with the SCADA system? If I want to blow up things, happened. ThyssenKrupp in Germany, lost manufacturer by someone exploded it. Gas pipeline from Azerbaijan to Turkey, lost it.
What happened there, actually? You said that it was...
Russian hackers found out that the security cameras were A, connected by Wi-Fi, B, connected to the SCADA.
Wow.
So they came close to the pipeline, which means to the network, hacked the security cameras from there, migrated to the SCADA system, changed the flow of gas, huge boom, end of pipeline. The reason that we know it, by the way, they were good enough to delete the database of the cameras, but one camera was connected to a different database which was not deleted, and this is how it is known that that's the way that the attack was launched. But even if you don't want to talk about those highly targeted and capable attacks, let's talk about statistics. Malware, cryptoware, they encrypt your manufacturing line, and now you have to pay for it.
Or the ransomware, yeah.
The ransomware, exactly. And it happened, we were involved in 3 cases in the last 6 months.
Wow.
Ransomware on the manufacturing line.
What you can do in this case?
Pay the money.
Pay the money. Okay, so if you have an early warning on some kind of ransomware that might affect your infrastructure because you're using, for example, Linux server and maybe some specific technologies that you know that there are exploits, then it's like an early warning, or what?
Either they mention your name or the specific technology, or they are interested in a specific industry, and you suddenly understand that you might be targeted, healthcare, for example, and a lot of things like that. That's about talking about SCADA. When you move to IoT, that's a similar but totally different story, because IoT we all have at home. You want to have your smart lights at home that you can turn on, and you just
the smart TV, the smart watches. There are a lot of personal data that you can extract from it, and I'm not talking even. I'm not even mentioning the fact that you can penetrate through that, your own PC and start to extract, let's say, sensitive information.
Right. Most of these devices don't have any kind of firewall, antivirus, any means of security. Some of them are strong enough to have encryption and security. So they are wide open lamps. Yeah. What is the size of the chip inside? How strong can be the encryption? So you get into it. So you think, okay, what's the story with the lamp? But the lamp is connected to the system, and you can jump from that and go somewhere else. We were doing some security monitoring for a guy, and he had this kind of watcher that was monitoring every movement. We found it in the cloud. We were monitoring the guy and telling him exactly where he was.
Wow.
High net worth individual, someone wanted to kidnap him. That was very easy to do if you wanted. Talk about a security of a company. You have your printer connected to the internet, Wi-Fi open, whatever device that you have the guys that are working in the office and they have their open devices. The system is wide open. There are no more boundaries, no more walls today. The companies are open and you can't even shut it. You have your cloud problems and challenges. You have the IoT challenges. And that's why I say prepare your letter.
Yeah, so prepare the letter. And we want to find, a most pragmatic, effective way to monitor, and at least to know in advance, so we'll have enough time to prepare. Do you have any kind of recommendations? Speaking about IoT and SCADA.
At least today, what we can see, and that's a learning by experience, what happens is the hackers don't do reverse engineering and hack. Okay. What they wait for is for someone, security guy, to find something and then release this exploit, and usually someone also writes some proof of concept, and then they just download it, go to Shodan, find out all those IoTs that are relevant, and they just infect them.
So they use the time between the CVE, when they actually publish the exploit, until the fact that it's actually being deployed and patched in all the devices, and use this time period in order to enjoy it, in quotes.
Exactly, only one thing. In IoT, they don't patch. It's not Windows system that is being automatic patched every Tuesday once a month.
Oh, wow. Okay, this is another example of a company called Cytex that actually is a major player in the SCADA domain. They actually write also the stack of software and also some controllers, and here you can see that you can download the Cytex SCADA. This link not already exists, but it contains sources and a lot of information that could be potentially hazard. That's all, folks. Before we'll go to the questions, maybe I will ask you, Itai, another question. We talked before about the Russians, about any kind of company, any kind of country. I don't want to be specific, but Do you see any trend in 2019? I don't know, Chinese, Russians, anything specific that you want to share?
I don't want to talk about trends regarding countries. There are trends regarding hackers are looking for money. They will go A, for places that they can find money or monetize on them, like ransomware, for example, or B, if they can't go to those places, go to this infection chain. But when we talk about countries, we must understand that the way that we thought up until not long ago, countries are countries, Stuxnet was a country against country, and it has nothing to do with us, doesn't work anymore. We all read the news. The US is applying pressure on Iran. Okay, what do you think that the Iranian hackers are doing now? Okay. We've already seen Iran attacking the banking sector in the United States. Okay. We've already seen Iran attacking the Sands Casino in the United States. What do you think the Iranians are going to do in the following few months?
I see.
And that's a nation with nation capability.
But I was referring more to the fact that, when we are talking about hacking, we see a lot of reuse. We even see hackers that generate technology for others, like, I don't know, DDoS as a service and botnet as a service. So what you can say about that? I mean,
about trends,
becoming like an Amazon of the hackers where everybody can buy in $5 something and start to use it.
Okay, two things about that. One, we see capabilities and technology migrating from the state level to the crime scene. We could see Russian technology that was used by the Russian government migrating to the Russian crime world. So one thing that the level, the sophistication of the hackers is going higher and higher. B, the crime world is being segmented and everything is being provided as a service. You can buy a malware as a service, you can buy the infection chain, you can buy the DDoS attacks, you can buy end-to-end service, you can buy even money laundering service if you want. Everything is over there. This means that if you want to be a hacker and launch an attack, you don't have to understand technology. You don't have even to have a characteristics like a hacker. All you have to do is go and pay the right people, the right amount of money, tens of dollars, not tens of thousands, not tens of millions, tens of dollars, and you have things being applied. When I talk to students, I always, laugh and say, why are you going and working like a waitress or something like that? Go to the darknet. This is what I teach. Okay, you can buy a malware, $25. You go to someone that sends the malware, like he sends 10 million, infection, 10,000 are being infected, 100 will pay, $300. So you talk about
statistics,
$30,000, a work of 2-3 hours. You don't have to know anything like a student. That works very well. We laugh at it. People respect the law. In our country, in the Western world, doesn't work in the Far East, for example. You see so many attacks being launched by people who are not capable because the service is being provided.
Very interesting. Okay, so we will finish here. Thank you very, very, very much, Itai, for sharing all this information and your experience. Anything else from your side?
What we usually say in our company, be strong.
And analyze like a hacker. Thank you very much. Okay, bye-bye.